All right, so in this video, I want to go through how we did the chromatography lab so that if you weren't here on Friday, you would be able to kind of see all the different parts. And then if you're absent and you didn't already have somebody getting data for you or making a chromatogram for you, you will be getting data so that you will be able to do all the calculations. So the first thing we did is to understand, hopefully you watched your 4.9 video, AP daily video, where it talked about separating solutions and also talked about chromatography. So chromatography is a way that we separate based upon polarity. So what we are using is chromatography paper, which is very similar to coffee filter paper. We're going to use two different solvents because we want to know which solvent works better to separate this solution. We're going to use a dye solution, which is just a mixture of food dyes. And we want to compare how they separate, how it separates in the isopropyl compared to the sodium chloride. So those are the two solvents that we're going to use. So in chromatography, you have a stationary phase and a mobile phase. Your stationary phase is your paper because it's not moving. Your mobile phase will be your solvent. So the solvent will travel up your paper, and as it travels up, it will pick up things that are similar to it and carry it along with it. So the rule is like dissolves like, so polar will go with polar, nonpolar with nonpolar. So if I have a polar solvent, any polar molecules that are in my whatever I'm trying to separate will carry along with it, and then will start to drop off as they're not as comparable. Whereas things that are nonpolar will not go with it. Vice versa, if I had a nonpolar solvent, then a nonpolar substance would want to go along with it. Once I get the chromatogram, then I'll be able to do some measurements. They're called the RF factors to be able to compare the movement. And then I can use that to identify any other substances, maybe an unknown substance. So this is kind of what our chromatograms are going to look like. This is one of them, one that I did earlier. When we get done, this is what another one looks like that I did earlier. So those are what we're going to be doing. So the first thing I need to do is set my line that's going to kind of be my starting line for my chromatography paper. Now it's important too that we're not touching the paper very much because we want to make sure our oils and things from our hands. So I'm going to go up about 15 millimeters and make it's a little bit more, make a line. I'm going to do the same thing on two of them because I want it to be fairly consistent just to make it easier on myself. So one of these is going to go into the sodium chloride and one is going to go into the isopropyl alcohol. Once I make a starting line, then I'm going to put a dot in the middle of each one. Now that paper or pencil dot is where I'm going to put my ink. So to get my ink, I'm just going to use a toothpick, get some on it, and then I'm going to just touch it to the paper and let that ink with the dye get on there. Now I'm going to do that multiple times so that I kind of get it nice and concentrated. So I'm going to do it a couple different times. Let it dry a little bit, do a little bit more. I'm going to keep it so it stays concentrated in that spot. So that I'm really getting a good amount on there. The size of the dots, it's nice if you're consistent. The main thing is you don't want your dot to be too low. So I'm going to let that dry. And while that would be drying, I would get my solvents ready. So I can either do this in a flask or in a beaker. I'm going to do it in a beaker. It's a little bit easier to see. So I would have my two solvents. So this is the isopropyl alcohol. This is the sodium chloride. So the directions say to get about 20 milliliters. It's really kind of arbitrary because it's really about you want to make sure that your paper is going to hang in your flask, but that it's not going, you can't have your dot touching the solvent. It will get wet as it travels. That's how it's going to separate, but you don't want your dot that we made sitting in the solvent. So you have to make sure that it hangs above. So the trickiest part about this is getting it set into the right position. So I've got my two papers, I've got my solvent. I'm going to kind of think about how high I need it to be. So I'm going to say, okay, if I want it to be about that high, I know that I need kind of about this much of it to kind of hang down. So that will put it so it'll be in my solution. Now I'm not going to hang it on the side. I'm going to hang it over a stirring rod just to help kind of keep it in place. And if I was using a flask, I could also use a watch glass to kind of hold it in place. It doesn't really make that much difference. Different people do it a little bit different. Because I want this paper to stay, I'm going to tape it and help it to stay on the top of this. So now, once I set this in, I should have it where it's touching the paper, which I'm not quite there, so I'm going to go a little bit farther down. Still not quite there. Again, like I said, it's a balance between not going too far, but going far enough. All right, so there I can see that it is touching the paper. Close, I can see that it's touching the paper, but it's not touching the dot. So I'm going to do the same thing, set up the same one, same thing in the other one. So, and then I'm just going to let it go. And once I let it go, I'm just going to let it go for a while until it separates. It gets fairly close to the top, maybe a couple inches, or I run out of time. So that should be pretty close on that one. So I'm going to put a little piece of tape to hold this one. Again, several people had to kind of redo this part because they put it in and then it would get wet. So I can see where this is not quite there. So I'm going to go a little bit farther down. And now it is touching. So I'm going to turn it so you can see it a little bit better. I knocked the other one. I can see this one is there also. You can already see that this one is starting to separate. I have this one that's now calling up. You can't really see it very well, but I can see where the solvent is actually already climbing up. Whoops, knock that out. And put it right back in very carefully. That's why this is not a professional. I can see where my solvent is traveling up. Now, those we're just going to let go for a while. So in class, we just let those go, and then we let them go until a certain time, and then we took them out. So I'm going to stop the video, let it go for a little bit, and then I'll turn it back on once it's progressed a little bit so you can see the progress. So now we're back a little bit, and you can see that both of them are progressing. The NaCl is a little bit farther behind only because I started that one second. You can see the isopropyl alcohol a little bit farther along, but they're both changing. So we'll let them go for a little bit. Pause it, come back again. Okay, a little time lapse. You can kind of see again the progress that we're making. It's not a fast process. It's kind of slow, but you can see how they look different depending upon the different solvent. Again, the one on the right, this one is the isopropyl alcohol. This is the sodium chloride. So think about the differences between an alcohol and a sodium chloride. So sodium chloride is ionic, whereas isopropyl alcohol is a covalent compound but has hydrogen bonding in it. So that difference will be important in why they do what they do. So we'll pause again and then we'll come back. All right, so for the just convenience of time and not letting it go too far, we're going to stop at this point and we're going to remove our papers from the solvent. And we do want to let them dry, but sometimes when they dry, they don't, some of the colors fade and things. So we need to be able to do measurements with them. So I'm going to take them out, lay them on this paper towel, and now I'm going to mark a couple things. I'm going to mark where my solvent front was, and I'm going to mark with my solvent front is here, because I'm going to need that so you can see that I marked those. Then I'm going to need to mark my colors. So here I can see this one. It's hard when they're wet, but even if you go back to it later on, you want to get some kind of outline there before they start blending in. So I have this, and then I'm going to let it sit and see the ones that we did before that I already showed you. And then once they dry, then we're going to do the calculations. So that'll be a different video that you'll see of how to do the calculations. But that is how we perform the chromatography experiment.